Hi, and welcome to the third lesson of the series How to Create in 72 Hours, a serious game that hits the mark. The topic of this lesson is Break Your Limits. In this lesson, I'll talk about how we created some game systems based mostly on programming and art that were totally new for us, so we break our limits, learning new things useful also in the future. The first subject is the Unity Google Sheets communication. I'm going to explain you why and how we created it, showing you the higher level logic and the code. The second subject is the card swipe mechanics. Also for this topic, I'll explain the logic, showing also the code. The final subject is how we face the art challenges, so the art direction and the creation of the assets without an artist in the team, improvising ourselves as artists. The Unity Google Sheets communication is the third subject of the lesson because it's the perfect example of experimentation with a new system that we wanted to create for a long time, but we didn't have the time, so Locked was the perfect playground to create it. The first question that you have to ask yourself when you make something is why I'm doing it. So I will explain to you why we made the system. The first reason was to avoid the bottlenecks of the standard cards creation pipeline. I will show you with a quick scheme what I mean. The standard pipeline starts in this way. The designer creates an Excel with all the cards in which he makes the balancing, creates formulas and stuff like that. The programmer creates a card object in the engine that is very similar compared to the structure of the cards in the designer sheet to keep the consistency. Third, the designer has to insert manually in the card objects all the cards created in the sheet. The problem is very visible. He has to create the cards twice, the first time in the sheet and the second time in the engine. And the problems didn't end here. Imagine if you have to balance some cards or change some text, you have to do it in both the systems. Otherwise, you have the sheet with some changes but the game without them, or vice versa, creating annoying problems in which you have to check all the cards in order to find the wrong ones. So the problem is to avoid the transcription phase that the designer has to make every time he has to add, modify or remove a card. The second reason is to avoid human errors, because the more steps a person has to manually do, the higher is the percentage of making errors, because humans are broken and the computers are the best in doing repetitive actions without making errors. So the automatization is the key to have a solid and efficient production. It's smart to invest a certain amount of time in creating automated processes to earn time during the production. This also allows to reiterate things more for a better polishing, since it's very quick. And your error rate decreases because humans have to do human-based tasks and not the repetitive ones. The last reason is because creating a tool like that is a lifetime investment. You use some time in a jam to create something that would be used every time you want, also in your B2B or official games. So it's a very smart investment because you test it in a jam project, spotting the problems, you fix it, and you can use a solid tool for your next games. Before I start explaining how we created the system, I want to give you some golden rules to apply during the creation of tools like that, because you have to create a useful thing for the designers, but trying to invest as little of the programmer's time as possible, because he has to code also the game and not only the tool. The first rule is the organization. The designer and the programmer have to design the tool together, deciding the variables, the structure, the UX, in a way in which it's usable for the designer but not too complex for the programmer to create. The second rule is to divide the system in little chunks and test them as fast as you can. So you analyze the difficulty of each chunk and understand which parts are too much time consuming and which are not. You have to absolutely avoid the approach, yes, I code all the system and I'll show you tomorrow. This is a common mistake. You have to test quickly. You don't have to create the whole system, otherwise you will be stuck on something that could be removed probably, and you lose a lot of time. The third golden rule is very linked to the second one. You have to be very fluid in your reasoning process, finding solutions and workarounds. In my experience, when there are technical constraints, the designer has to create a workaround, because the design is the less time-consuming part compared to the programming one. So it's your role finding solutions to problems in the most efficient way. It's no sense to make the programmer spend 12 hours to code the perfect tool when you, as a designer, could change or remove something that is not essential, so the programmer could code it in 2 hours. A very useful approach that I use is to design the standard systems, but thinking also at some secondary solution with the programmer. So use your brain to predict and solve the problems before they happen. The last golden rule is to design with the programmer a usable system with a good UX, otherwise the designer spends a lot of time trying to use it. The designer is the final user, so the tool has to talk the designer language, so avoid strange buttons labels as parse CSV strings to JSON, use a more human language as convert text. Okay, now we can talk about how we created the tool. The first step is to design a precise Google Sheet structure. This is ours. The columns are the card fields and the rows are the cards. The very important thing is to maintain the structure for the entire project, otherwise the match between the sheet and Unity code collapse. Testing on Unity, we noticed that uploading and parsing a CSV is slower than uploading a JSON. Specifically, with 500 cards, the CSV requires 55 milliseconds, when the JSON only requires 9 milliseconds. Considering that a big delay becomes lag, we decided to use a JSON, but Google Sheets doesn't allow us to export directly in a JSON format, so we had to export first as a CSV and then use a script to convert and create a JSON that will be used in the game. In the CSV format, we can use different separators. The most common ones are the semicolon and the comma. Here in this Google Sheet we have this table as an example. You can notice that exporting in a CSV, the separator it uses is the comma. So a technique to obtain the content inside of the separated cell could be using the split on the comma character. This works until we don't use the comma character directly inside the cell's content, like in the second example. In this case, when we export the CSV, you can notice that the cell that contains the comma gets encapsulated inside quotation marks. So if we keep using the split on the comma to obtain the content of the separated cells, you can notice that the result is wrong. When we export a table in the CSV format, we have a one-to-one reference between the lines of the table and the lines of the CSV. So for us, every line of the CSV corresponds to a card. Moving forward with the development, we notice that if we use some spaces inside a cell, like in this case in the example number 3, the space gets put in the CSV, splitting the line into two separated lines. We don't want this. Since we use Text Mesh Pro inside Unity to show the text, we can use also the HTML tag BR to start a new line. So we replaced all the spaces inside the cells with the HTML tag BR, like in the example 4, obtaining this CSV as a result. Doing this way, it was possible to keep the formatting in the game. Let's get to the analysis of the logic behind our algorithm. First, we need to read all the text, the content of our CSV. Thanks to this function, we can read the content of a file and keeping it separated by lines. This is convenient since each line represents a card. We then use a list to save the position of the commas, so the separators of the cells, and we use a variable to know if we're inside quotation marks or not, in order to understand if the comma is a separator or if it is inside a cell. Here we have the list where we save the position of our commas, so of our separators, and down below here we have the flag that we use to understand if we are inside quotation marks or not. As an example, this is the string we will analyze. Starting from the first character, we instantly find a quotation mark, so the flag gives true. And from here until the next quotation mark, we will ignore all the characters, including this comma. Once the quotation mark is found again, the flag gives false, so the commas we will find from now will be considered cell separators, unless they will be again inside quotation marks. Indeed, this comma is at the position 8 and is a cell separator, and so its position is saved inside the list. We continue like this until the next comma at the position 14. It will be saved in the list as well. For convenience, we also save the length of the string inside the list, so that we can manage without any issues also the last cell, without having to consider it as a special case. Now we can cycle the list containing the position of the separators, and thanks to the substring function we obtain the content of the cell. The content of the cell will then be given to the function replace to remove the quotation marks if there are any. For this reason, we decided to not use quotation marks inside the cells so that we could avoid an additional layer of complexity. Now the property gets inserted inside the card object, Obviously, this mapping is done by hand, so if we'll ever modify the structure of the CSV, add some columns or modify the order, we have to check again the mapping. We keep on going also for the other properties, and once we are done, we have a complete card. We now can add it to the list of cards and get to the next line until all lines got finished. Now we have a list containing all the cards that got extracted from our CSV. All we have to do now is to convert everything in the JSON format. There is this function available that once you give it an object, it returns its JSON. This works if we give directly a card object. In Unity, though, we have a limitation. We cannot create a JSON by passing it a list. The workaround for this is declaring our list inside another object, in this case list container, and give list container to the function toJSON. By doing this, we can generate the JSON for the list of our cards. All we have to do now is writing the JSON on the file thanks to this function, so that we can upload it and use it right after this. In-game, instead of doing everything I have explained, except the creation and writing of the JSON, all we'll need is read the JSON and give it to this function to populate the object list container. By doing this, we got from having 55 milliseconds of delay to 9 milliseconds. Now I show you our final tool usage pipeline. First of all, we manipulate the sheet, creating or modifying some cards. We export the sheet in CSV format. We import it into Unity. We select the file and we click on Convert into JSON button. We go into the resources folder and we rename the new generated file with the name testang or testida based on the language of the cards. So we always have translated and updated cards with an effort measurable in 30 seconds instead of writing all the cards in the editor that would be unquantifiable. Our first idea was to create a swipe mechanic and feel similar to reins. So the card moves left and right based on the direction of the swipe, and it rotates also, creating a nice looking smooth movement. I show you directly in the engine our swipe card script that controls this mechanic. As you can see, we have a lot of public variables in the editor because we created a modular system that allows the designer to balance the game feel of the swipe. I start showing you how we achieve the rein swipe. First of all, we created the translation of the card based on the swipe movement, having obviously axis borders that creates the screen borders. In this example, I show you how with the value of 30, the card does not exit too much from the screen, but lowering the value, the card exits much more from the screen. Second, there is the translate restore speed, so how fast is the card returning to its initial position when you leave the swipe. Third is the translation speed divided by axis. It means how fast the card moves during the swipe. So in this example, it's very fast. Lowering the value, you have to make a long swipe because the card moves slow. So with these variables, we created a very basic translation movements. Now I show you how we created the rotations. The variable swipe rotation enables the rotation, and as you can see, the swipe mechanics feels very similar to the reins ones. We have also integrated a feature. If you start the swipe in the lower part of the screen, the card rotates having the pivot in the lower part of the screen. If you start the swipe in the upper part, the pivot is up, so the swipe rotation is different. Another variable is the max angle of the swipe rotation. In this example, I increase a lot the values so the card rotates a lot during the swipe. The next variable is the swipe speed, so how fast is the card performing the swipe. So in this example becomes really fast because I've increased the value. The next variable is the rotation restore speed, so how fast is the card returning to its original rotation. In this example I decrease the value so the card is extremely slow. Increasing the value, the cards increase the restore rotation speed. After this system, we found a very useful reference of a Nike app. in which there are very cool and smooth cards, movements and transitions, so we decided to integrate also this part in our system. As you can see, I turned off the swipe check, so I disable the range system and I activate the swipe lateral movement. The card rotates also on the z-axis during the swipe, so the feeling is more dynamic. The first variable is the max lateral angle. Increasing its value, the card rotates a lot during the swipe. This example is extreme, but it's only for explaining. Increasing the swipe lateral speed, the cards move faster during the swipe. The last variable is the rotation lateral restore speed, so how fast is the card returning to its original rotation. Now, having all the system integrated, we can do a very cool thing, combining the two. I activate also the swipe checkbox, so we have a blended system between Reigns and the Nike app. Now I want to talk about a very specific thing that could be very useful in order to create rotations like the ones in our system. We manage the hierarchy in this way. We use a nested hierarchy to manage the pivots on which the card rotates. The first object is the front card in the center because it's the container of everything. We have the object card up for the rotation when you swipe in the upper part of the screen. We have also the card down, that is the opposite of the card up. These two variables affect the range type of movement. The lateral rotation is managed thanks to the card left and card right objects. We know that it's not the perfect system, but at the jams the important thing is to achieve a result. So don't waste time doing the most polished and efficient code. The last subject is how we approach the art without artists in the team. The first thing to do when you're in a known field is to be honest about your limits. You have to understand what you are sure to know and what you think you know. So honesty and not overrating yourself is the starting point. An example of our limits was, we don't know how to create realistic or cartoonish style, but we are good at making UI for apps because we did it in the past as UX and UI designers, so we can create a product with this style. A very important thing to do before you start to make the art is to set your artistic objectives. What is the style? What I want to communicate with it? What is the mood? What is the information hierarchy? As everything else, art is fundamental in your game. So if you don't want to reiterate it several times, you have to create objectives that behave like a light in your path. A very useful tip is to compensate the lack of artistic knowledge using the game personality. So the style, the mood, the details have to be very outstanding. So even if you don't realize the perfect looking game, there are some hooks that make players say, this is interesting because it's strange. Almost always people remember a not perfect style but with personality compared to a beautiful one without personality. The last suggestion is that the references are your secret weapon. You don't have to create something new, try to combine existing stuff in new ways supporting your game experience. We spend a lot of time searching for references because you have a visual representation of the artistic possibilities that you can blend together. Our method starts creating an art and mood board with all the references gathered on Pinterest divided by style. We use Figma as the art creation software, which is a very powerful tool similar to Adobe XD, but it's completely online and people can work together at the same time, so it's perfect for team working. When you choose the styles for your game, don't focus only on the first idea, choose at least two. Indeed, we choose a minimal and flat style and the opposite one, so a very cyberpunk and dark style. Then we created a mockup for both the styles. With the term mockup, I mean a prototype of your art styles over your game screens. Your objective in this phase is to understand if the art style works well. You don't have to create the final assets to use in the game, so avoid all the polishing stuff. When you have the mockups ready, it's time to do some A/B testing with external people, asking what they prefer and what kind of emotion each style generates. After the external feedback, you have to use your previous art objectives as a lens, asking if your styles support your game experience. In our case, both the styles were not good. The minimal one was too minimal and didn't give the feeling of interacting with real people, because any social network in real life has a similar style. The cyberpunk version was too dystopic and anxious, and the players perceived it as a game and not as an app. The reason was the palette selection, since it can alter moods and change the perception. Making the colors too saturated and bright resulted in a futuristic, video game-ish and too much anxious style. So we tried to find a reference that could solve all the problems, and we found Orwell. A very nice game with an art style that feels like a social network of the future, with a fair sense of anxiety and dystopic thing. So we adapted it to our needs and we designed the final art style for Locked. Now I will explain to you our art creation pipeline so you can use it for your games. The first thing is to create a vector asset on Figma or in the software that you are using. We use vector files because our style fits well. If you're making hand-painted stuff, obviously you can create vector assets. The second step is to export the file, deciding the format and the resolution. It's very cool that in Figma you have an export multiplier that increases or decreases the image resolution based on the value that you type in. Third, very important, is to integrate the asset into Unity to evaluate if it works or not. You have to do it as fast as you can, otherwise you continue to create assets in a certain way, not knowing if they are good. After the import of all the assets, you have to understand which ones are too heavy in order to reduce their size. There are some techniques. The simple one is to create images with a multiple of 2 resolution, so you can use the various compression techniques in Unity. Otherwise, you can directly export the image with a lower resolution. This third lesson is finished. We analyzed some of the most important systems of our game. In the next lesson, we're going to talk about the card design method we use in order to create a bunch of cards and how we balance them. The second topic is how we display the information in a graph. Third, why it's very important asking for feedbacks during the development, also in a game jam. And the last one is how we created a tutorial from a design point of view.